So, hello. Now my group will present about some application of matrix.
Well, the matrix can be used to form model for population growth. The first step in this process is to group the female population into 8 classes of equal duration. For example, if the maximum lifespan of a member is m years, then the n intervals below represent the 8 classes. The age distribution vector is represent the number of female population member in each age class, where each one is a number in the first age class, each two is in the second age class, and so on. Over a period of m on n years, the probability that the female member of the age class will survive to become a member of the I plus 1 age class is pi, where pi between 0 to 1 and I equal 1. I run from 1 to n minus 1. The average number of female offspring produced by a member of the age class is Bi, where Bi is larger than 0 with I run from 1 to n. Multiplying this age transition matrix by the age distribution vector for a specific time period produce the age distribution vector for the next time period. We have the formula that L h equal to h plus 1 with j run from 1 to n. For example, a population of female animal has the characteristic below, and it is also given that the population now consists of 1,000 female animal in the first age class, 1,000 in second, and 1,000 in the third. How many female animal will there be in each age class after 15 years? Let H1, H2, H3 be the number of female animal in age from 0 to 5, 5 to 10, and 10 to 15, respectively at time t. Then the current age distribution vector is H1. The number of female animal in age from 0 to 5 after 5 years is H1, and we know that the female animal in is produced in the first age class is 0, in the second is 4, and in the third is 3. Therefore, we have the equation that H1 will equal to 0 times 1,000 plus 4 times 1,000 and 3 times 1,000. Do the same, we will have the equation of H2 and H3. And those equation in the matrix form, we will have the age transformation matrix is L. And after 5 years, the age distribution vector is H2 equal to L times H1. Do the same, and we will have the answer, the vector for after 10 years and 13 years and 15 years.
So there are many types of application involved a finite set of state S1 to Sn of populations. For instance, the resident of a city may live downtown or in suburbs. Substring concern summer may buy Coca, Pepsi, or other brands. The probability that a member of our population will change from the J state to the I state is represented by a number of Pij, where Pij is from 0 to 1. So in the next definition, the matrix P, P1 to Pn N is called the matrix transition probability. At each transition, each member in a given state must either stay in that state or change to another state. It means that the N from I from 1 to N Ej is equal to 1, where J is from 1 to N. The next definition, the n-state vector of a Markov chain for which P is matrix of transition probability and x0 is inertial state vector is xn equal to P multiplied by x n minus 1 or is equal to P power n minus multiplied by x0. So in a consumer preference model, to competing company offer a satellite television to service to a city with 100,000 households. We will have a figure of company A, B, and they ask how many suppliers will each company have in 1 year, 10 years, and 15. So we will have a following diagram. And the solution, the matrix of transition probability is P, and the inertial state vector of representing the portion of total population in the free state is x0. To find the state vector representing the portion of the population in free state in 1 year, multiplying P by x0 to obtain the x1. Do the same and power P by 10, we will get the number up to 10 years and so on for the 15 year. The limited input, consider an economic system that has an different industry. I1 to IN each having the input needs and output in producing each unit product. An industry may use other output of other industry, including itself. For example, an electric utility use outputs from other industries, coal, water, and also use its own electricity. We let the DIJ be the amount of output the J industry need to from the I industries, and the matrix of this coefficient is the input output matrix. So in the example 3.1, we consider a simple economic system at the following one. And we need to find the input output matrix for this system. So how do we do it? The column entries show the amount of each industry required from the others from itself to produce 1 unit of output as the matrix need. The row entries show the amount of each industry supplied to the others and to itself. Let the total output of the I industry be denoted by Xi. If the economic system is closed, that is, the economic system sells its product only to industry within the system, then the total output of the I industry is Xi equal to Di1 multiplied X1 plus Di2 multiplied X2 and so on to N. If the industry within the system sells products to non-producing groups, such as governments and charitable organizations, outside the system, then the system is open and total output of the I industry is the Xi do the same, but with plus to EI, where EI represents the external demand for the I industry's product. The collection of total output for an open system is the following ones, and the matrix from the system is X equal to D multiplied X plus E, where X is the output matrix and E is the external demand matrix.
For example, a simple economy might be divided into 3 sectors: manufacturing, agriculture, and utilities. We will be concerned with economies with one open sector, and our primary goal will be to determine the output level that are required for the productive sectors to sustain themselves and satisfy the demand of the open sector. Assume that input and output are measured in dollar and that the input required by the productive sector to produce $1 worth of output are in accordance with the following table. Suppose that the open sector has a demand for $7,900 worth of manufacturing product, 3,915 worth of agricultural product, and $1,975 worth of utility. Can the economy meet this demand? And if so, find a production vector X that will meet it exactly. An economic system composed of three sectors has the input-output matrix D and find the output vector X when the external demand are E. To meet the outside demand, the vector X must satisfy the Leontief equation, which is equal to D times X plus E. Then we can find the matrix X. The economy can satisfy the demand of the open sector exactly by producing $27,500 worth of manufacturing output, $33,750 worth of agricultural output, and $24,750 worth of utility output. Well, thanks you for your attention and thanks for listening.